All right, let's talk quickly about sex-linked traits. So the difference between a sex-linked trait and a regular like Mendelian trait or Mendel trait is that we have to take into account the X's and the Y's on the chromosomes, because these are going to be traits that are on either the X chromosome or the Y chromosome. So if we look at hemophilia, hemophilia is a X-linked recessive gene. Okay, so here's what that means. It means that, let's take a female, okay? A female can either be, remember females are two X's, okay? So a female could even be, and we'll do H for normal and little h for hemophilia, okay? So a female could be homozygous dominant, so they could have a capital H on each one of their X chromosomes. They could be heterozygous, or a female could have hemophilia, which would be X and two little h's. So the letters really work the same as the dominant recessive Mendelian traits. It's just that we're going to put them on the X chromosomes. Okay. Now remember, a male is an X and a Y. Okay. So a male, since they only have one X, they're only going to have one chance of carrying the gene for hemophilia because it's not found on the Y chromosome. So you could be dominant. So the dominant allele could be normal on the X chromosome, or you could be recessive. Now, if you look here, these are going to work the same. As long as there's a capital H, you're going to be normal. Hemophilia is a blood clotting disorder. But if you have the two recessive and there's nothing to dominate over it, that capital letter, then you're going to end up having the disease. Okay, it's a recessive gene. So that's what that means. So in a man, because they only have one X, there's only two possibilities. They're either normal because they have the capital letter, or they're not because there's no chance to dominate over that because there's not another X, there's a Y. Okay, so let's say, for instance, that we have a carrier for hemophilia. Okay, a carrier is someone that's heterozygous, a woman that's heterozygous, meaning that she's normal, she doesn't have the disease, but she carries the disease gene on one of her X chromosomes. So we have a carrier, and they're going to mate with, let's say, a normal male. So it would be capital H. You're going to do your Punnett square. Okay, so we'll put, mom up here, big H, little h, and we'll put dad along the side. He was normal, so it's a capital H and a Y. And you're going to fill these in like you did before. So we got XX, capital H, capital H. So we got a normal female. We got X, capital H, X, little h. So another normal female, but a carrier. We have X, capital H, Y. So we have a normal male. And we have X, little h, Y. So a hemophilia boy. So of these children, there is a 1 in 4th chance of having hemophilia. But there is a 50% chance if it's a male. Right? Because there's two males here and half of them have hemophilia because half of them have the H. So a lot of times all the times with X-linked recessive genes, the male is affected at a higher rate than the female because the female has two X's, two opportunities to maybe mask that recessive allele, the two double H's. A man doesn't because they don't have two X's, they have a Y, and that gene is not found on the Y. So first figure out what your mother is. Okay, so first put your 2 X's down for the mom and then look at the trait and figure out what their letters would be, just like a Mendel trait. Then do the same for dad, figure out their letters, X and Y. Dads are always will be X and Y's, okay? And then put their, if they're normal, they'll be dominant. And if they have the disorder or whatever gene it is they're talking about, then it would be a little h. And then fill your Punnett square in, really focusing on the H's, but the X's and the Y's are going to tell you whether or not they're males or females. Hopefully that helps.